In this video lecture, let me discuss about the theories of corrosion. The theories of corrosion can be classified into two types, dry corrosion and wet corrosion. Dry corrosion is otherwise called as chemical corrosion. Wet corrosion is otherwise called as electrochemical corrosion. Dry corrosion is nothing but the direct chemical action on the metal. Wet corrosion may be due to either the two different metals exposed to electrolyte or one metal exposed to different electrolytes. The types of dry corrosion: corrosion by oxygen, corrosion by hydrogen, corrosion by other gases, liquid metal corrosion. Corrosion by oxygen mechanism: consider a metal M. It undergoes oxidation and forms Mn plus and release electron. That electron is utilized by the oxygen and it forms oxide ion. Oxide ion and the metal ion react together and form metal oxide layer. And this oxide layer can either be stable, unstable, volatile or porous. Stable oxide layer: when a metal is exposed to oxygen, oxide layer is formed and this oxide layer is protective. So this oxide layer will protect the metal. Unstable oxide layer: metal exposed to oxygen and oxide layer is formed. That oxide layer will decompose and metal is further attacked by the oxygen. Volatile oxide layer: metal is exposed to oxygen, oxide layer is formed, but the oxide layer is volatile and freshly metal surface is exposed to oxygen, and this type of oxide layer will lead to excessive corrosion. Porous oxide layer: metal is exposed to oxygen, oxide layer is formed, and this oxide layer contains pores. Through these pores, further corrosion will occur. Example for stable oxide layer include aluminium, tin, lead, copper. Example for unstable includes silver, gold. Example for volatile is molybdenum. An example for porous is iron exposed to hydrogen sulfide environment. Corrosion by hydrogen. Corrosion by hydrogen is of two types: hydrogen embrittlement and decarburization. Consider a metal iron. It undergoes oxidation when it comes in contact with the hydrogen sulfide environment. Iron undergoes oxidation and form Fe2 plus and release the electrons. Hydrogen sulfide split as hydrogen ion and sulfide ion. Sulfide ion react with the Fe2 plus and forms iron sulfide. H plus ion react with the electron and form H2, that is, atomic hydrogen is converted into molecular hydrogen. This hydrogen will diffuse into the minute cracks and it will increase pressure in the voids and thereby it will lead to embrittlement. Embrittlement due to hydrogen, and hence the name is given as hydrogen embrittlement. For decarburization, consider the alloy steel. It consists of iron and carbon. When steel is exposed to hydrogen environment, iron undergoes oxidation and forms Fe2 plus and release the electron, and this electron is utilized by the hydrogen and forms H plus ions. Here the molecular hydrogen is converted into atomic hydrogen. This atomic hydrogen combines with carbon of steel and forms methane, and thereby it will decrease the carbon content in steel, and hence the name is given as decarburization. Corrosion by other gases. Example, sulfur dioxide, chlorine, carbon dioxide, etc. For example, consider the environment is chlorine and the metals like silver and tin is exposed to chlorine gas. Silver forms silver chloride and this is non-porous and it will protect the metal silver. Whereas tin forms tin chloride which is volatile layer, non-protective and thereby it will lead to excessive corrosion. Once the layer is volatile, again fresh layer is exposed to the chlorine environment and thereby it causes excessive corrosion. Liquid metal corrosion. Consider a liquid metal is flowing over the solid metal. Two things can occur, either the dissolution of the metal or the liquid metal can penetrate into the solid metal. Wet or electrochemical corrosion. So, two conditions, either two different or dissimilar metals exposed to electrolyte or one metal exposed to two different electrolyte. Consider two metals, iron and carbon, and this is exposed to an electrolyte. Consider the environment is neutral, water. Here the more active metal undergoes oxidation and the less active metal undergoes reduction. So iron will act as anode and corrosion occurs on iron and copper will act as cathode. Consider the metal iron passing through two different earth materials. One is clay, the other one is sand. Since clay is less aerated, it will act as anode and sand is more aerated, it will act as cathode. And the portion where the metal acts as anode undergoes corrosion. Mechanism of wet corrosion. Consider the metal iron. The anodic reaction is oxidation. So iron forms Fe2 plus and release the electron. Here the cathodic reaction can be of two types depending upon the two different environment. So here first you can consider the acidic environment. So when the metal ion is exposed to acidic environment, the H plus ions take up the electron released by the ion and hydrogen gas is produced and fill the voids in the metal. Since hydrogen is produced, this type of cathodic reaction is called as evolution of hydrogen. Consider the metal ion and this is exposed. This will undergo oxidation Fe2 plus and release the electron. Now the environment is neutral or alkaline. Consider for example neutral water. Water takes up the electron in presence of oxygen and hydroxide ion is produced. Here either you can consider oxygen is absorbed or you can consider the formation of hydroxide ion and hence this type of cathodic reaction is given as absorption of oxygen or formation of hydroxide. The hydroxide ion and the Fe2 plus ion move towards each other and form ferrous hydroxide. It's nothing but the rust. So in between the portion of anode and the cathode, the corrosion product is produced. Here you can see the reactions. So iron gives Fe2 plus and release the electron. This electron is utilized by the water molecule in presence of oxygen, produces hydroxide ion. The Fe2 plus and hydroxide ion combine and form ferrous hydroxide, next ferric hydroxide and iron oxide in excess oxygen, and iron oxide is nothing but the rust corrosion product. Thank you for watching this video lecture.